Okay, so
as the moon has now moved, the sun is appearing again, and we can see the diamond ring. It's amazing. It's fantastic. You see the outer edge. I see prominences, little red pieces of chromosphere from the lower atmosphere. This is amazing. This is absolutely amazing.
Jody, what we got?
It is,
that looks pretty cool.
I mean, it's breathtaking. I just, even seeing it right now through the TV, it's just an amazing thing to see. I cannot imagine what we're gonna feel here in South Carolina when we have our chance.
Well, I hope we have our chance to, Sean, and, get that weather up here looking good here in Charleston. Now, what do we...
So, Alex...
Alex, what are we seeing here?
Is that from the G3? That looks like from the G3 because I see spectra there.
No, it's still from Salem.
That's still from Salem.
Yeah.
Okay, so you're seeing the bright, actually the camera is causing a little prism effect there, and you're seeing the bright light from the edge of the sun. So that is really beautiful. That's sort of the edge of the diamond ring effect.
Yeah.
So, Alex, a reminder, Alex, so when that diamond ring pops up, that's when people should put the
That's when people should put your glasses back on. So when you see that diamond ring after totality, that's the signal to you that it's time to put it back on.
Yeah.
So look now, we see the corona in Madras. That's gorgeous.
That's amazing. I mean, being able to look at that with your own eyes is an amazing experience. And that only can be seen when you have this kind of totality.
So the corona, that's the
solar atmosphere.
That's what solar scientists really live for, right?
Right. Right. That is the origin. That is where the origin of space weather. That's where it comes from.
That's where most of the solar flares and the corona mass ejections, big explosions of particles, originate from.
Now, if there was solar activity, would we see it right now? Would we be able to see that popping up on the sun?
If there was a coronal mass ejection leaving the sun, we could see it there because, in fact, we have seen it in the past, and I'll even show some history later with images that people drew of these coronal mass ejections leaving the sun during a total solar eclipse.
Now, why is it so critical and so important to really get this type of view from the sun's atmosphere from the corona? Johnny?
You mean like in a total solar eclipse?
Yes. There's the diamond.
That's the diamond ring again. That's amazing. That's from Madras.
Wow.
It is important to do this because we do this kind of eclipses artificially, but we do not do it as perfect as nature does. The moon covers the sun in such a perfect way that we see parts of the corona that we don't usually see.
So Alex, explain that and safety too, right?
So right now, this was the moment when you see that flash of light. That's the moment when it's time to put your glasses back on or start using your indirect methods because now it's too bright and it could damage your eyes.
Yeah. Safety first, people. Always.
Wow. So the folks in Salem, Oregon, I mean, they're like juiced. I mean, they got it. They got the good.
They've got a perfect view, and they are seeing one of nature's most amazing spectacles.
I can only imagine the reaction on the ground from the folks there.
Oh, they are probably
gasping.
Completely overwhelmed right now. Completely overwhelmed.
Well, I certainly hope we get something like that. But we've got it here on NASA television through the eyes of NASA. And we got the International Space Station coming up and other images only we can bring.
Only NASA can bring, yes.
Now, is it completely dark or is it coming out?
No, what's happening now is the filters are back on, the safe solar filters for the telescope, and now you see the crescent, which is the sun, basically now being revealed after the eclipse. So we're now back to the partial phase in the other direction.
Exactly.
Now, how fast is this going?
Well, this shadow is passing across the country, depending on where you are, anywhere from 1,200 to 1,800 miles an hour. So this is moving incredibly fast because the moon itself, in its orbit, is moving at almost 3,400 miles an hour. And that, in combination with the rotation of the Earth, is what gives us a shadow moving that fast.
Okay, so, Gotti, let's talk about space weather. Seeing this in space weather is so important. So just let us really understand why it's important on space weather.
So space weather is pretty much the conditions created outside in space due to the sun. We look at space weather because we want to understand these conditions. If you look at the image that you have now, you're going to see SDO image, the Solar Dynamic Observatory. That's where we actually look for the source of space weather, where the solar flares and the coronal mass ejections actually originate from. Well, when we look at SDO, at the images, we also have to look at artificial eclipses, like the one that you're looking at online now. These are actually from the SOHO spacecraft. These are the artificial eclipses that I was talking about, Dwayne. Like this, you have to block the solar surface to be able to see the solar atmosphere, the outside corona. But you're gonna see something like this today, and you saw it. But you're gonna see it better because nature does it better than we can actually do it artificially. Right now, the activity is not, there's not too much going on in the sun. However, if I do a historic event, which actually was from this past July, you can see a coronal mass ejection, this big explosion of particles that come from the sun.
Well, those look pretty intense. Do we have to worry about that? That doesn't look good.
Well, you know, space weather, what can actually do is affect communications. We have the magnetic field of the Earth to actually protect us. It's our shield. And what we do is we actually can analyze that using real-time models like the one that you're seeing on the screen, that we actually understand how the magnetic field of the Earth changes with those coronal mass ejections. But space weather can affect communications, satellite instruments, and power grids.
Okay, so we're going to toss to Idaho. And I think we've really got some good stuff here. Gay Hill, are you there in Idaho Falls?
I am absolutely here, Dwayne Brown. In fact, looking through the glasses right now, it's so weird. We have a crescent sun instead of a crescent moon. This is the, I think we haven't had a total eclipse here in Idaho Falls since 1889, 128 years ago. And things have certainly changed in Idaho Falls since then. There's a whole lot more people, especially with all the visitors in town. We're just outside the Museum of Idaho, and we have partnered with the museum to make this an official viewing site for Idaho. And they right now have an exhibit on space, but we also sent in a team of experts. And for the past 3 days, we've had talks, we've had demonstrations, we've shown them visualizations such as eyes on the solar system, and we've shown them artwork. But really, the order of the day is the eclipse, and NASA has that covered too. They have sent an army of volunteers. We call them solar system ambassadors. They are all along the path of totality, and they're volunteers. These are people just telling people what they're seeing and helping them understand. We have one here, right here. His name is Richard Stember. Hey, Richard. He has been manning this mobile observatory, and that is what is providing our solar telescope shot right now. Now, we asked him, what's it like being a solar system ambassador? And he said, follow along. We did, and we went with him to a school in Southern California. Take a look. We apologize, there is no audio on that video, but it talks about the solar system ambassadors. There are about 720 in the United States. They get special training from NASA. They learn all about the missions and about the science, and they basically go out to public events all over the country teaching them about NASA missions. If you would be interested in becoming a solar system ambassador yourself, you can. We have a website. Look it up. up Solar System Ambassadors. It is a NASA website, and starting September 1 through the end of the month, you can sign up to be a Solar System Ambassador. So check it out on the web, Solar System Ambassador. With me now is Jim Green. Jim Green is the head of planetary science for NASA. He's in charge of all planetary missions and asteroids. This guy knows his stuff. Let's talk about this. Now, you see this eclipse that doesn't happen. It happens once in a lifetime.
Wow.
But as a scientist, you see it as an opportunity.
Oh, absolutely. I mean, we're getting the eerie feeling right now, but when we launch balloons, and there'll be 57 balloons along the path, 30 of which are going to have a planetary experiment on them.
And we have video of this. Now, just a few days ago, we had a crew here. They did a test launch for us, and they sent up an imaginary payload for us just to see how it all works. You have actual scientific experiments going up.
We do. We have a bacillus. It's a harmless bacteria. We have on 30 balloons 2 coupons where the bacteria will be sprayed. One will stay on the ground, one will be affixed to the balloon. It then will go up to 100,000 feet above the ozone. So the ultraviolet light, also blocked a little bit by the moon, is just like Mars. In addition to that, the temperature and pressure will be just like Mars. So when the balloon goes up higher and bursts, comes down, we'll retrieve that coupon off the balloon, match it with the one on the ground, and then we'll see how many survive.
Now, why is that information so critical for Mars research?
Well, this bacteria is pretty much everywhere. It's very hardy, and it probably has made its way to Mars, perhaps even on our rovers. And I would like to know if that environment is so harsh that it would eliminate that bacteria or not.
All right. I'm being selfish. I have never seen a total eclipse. And I'm sorry, I would love to talk to all of you people, but I want to put on my glasses too and take a look. Can we continue this conversation?
I have to do this too.
All right, and watch, and we can talk. All right,
oh,
so
what
we
a
still
little sliver.
Just a little sliver of the sun right now. And let's talk about this. Why is this so rare?
Well, you know, the plane of the moon relative to the Earth's sun line is tilted by 5 degrees. And so there's only 2 places where the moon and the Earth and sun are on that same line. And that's why every 18 months or so we get an eclipse.
The shadow is 1 minute out of
1 minute away. Wow.
The crowd is getting excited.
Wow. It's already so eerie.
Oh, wow, it just got dark all around us. And you can feel the temperature getting colder
Oh,
here.
yeah. The winds are really picking up. You know, this dark area, the winds are just flowing in.
Oh, you can, it's just a tiny, tiny sliver right now. It's all closing up.
There it goes. It's going. Getting smaller. Oh, wow!
Oh my gosh!
Oh, look at the ray structure. You can't get that on film. There's Venus.
Oh wow!
There's Venus. Oh, wow. Wow. Oh, look at that ray structure.
You were saying this is the only way you can see the atmosphere.
Yeah, that lower part of the corona is really even hard from space to see. Wow. Wow. I got to spend a second looking around at the crowd. Oh my goodness. Yeah. Wow. Wow.
We should turn off the lights.
get ready to put them back on here soon.
Okay.
Pretty quick.
Have you noticed, Jim? The street lights are all on
Oh, the
around
street
us.
lights turned on,
We
of course.
confused the street lights.
Of course. Who would have thought that? We didn't plan that one.
All right, we should get ready for our glasses again. Get ready with your glasses.
Okay, there it goes. There's
Stand
the
by.
diamond ring. There's the diamond ring.
Oh my gosh.
Yeah, wow.
That is
Was
so.
that all right?
Oh my gosh. Whoa! Oh, that's brilliant.
All right. Wow.
Okay, glasses back on.
Too brief. Too brief. Too brief.
Okay. We're going to have to wrap this up pretty soon, Jim. That was incredible.
Way too brief.
Yeah.
Way too brief.
We got a minute 50 seconds.
Yeah.
That was all we had. Why is it that some parts of the country get a little more than we do?
Well, it has to do with the curvature of the Earth also. And so the shadow is at various altitudes. You could go up at a higher altitude and get also a great view too.
Well, this was a real treat. This was fantastic. So Idaho Falls has had its total eclipse. The next one is coming in 2252. We won't be here, but we hope NASA will. Back to you.
Gay Hill, that's Gay Hill from NASA's Jet Propulsion Laboratory. Gay, I'm jealous. I'm telling you, I'm jealous. So Alex, explain again that diamond.
Well, so the last bit of sunlight, when you see it at the very beginning, is when the last bit of the sun, the crescent, shrinks down to a little tiny bit. And at the same time, you can see a ring of the corona around it, so that makes the ring, and then that bright bit of crescent gives you the diamond. So when it reappears, you get the same thing. The last bit of corona is a ring. The flash of the sun is the diamond, giving you the diamond ring. It's a beautiful, beautiful sight.
And real quick, and then I'm going to ask you a question because there was something going on here in Charleston. The planetary, Jim Green said something about Venus. This is really cool for planetary science because you can see other planets, right?
Absolutely, and as a matter of fact, one of our missions through the WB-57 aircraft are studying Mercury, which is very, very close to the sun.
Okay, so we're gonna come back to you and we're gonna talk about what's happening here. So the next up, NASA's ready to take a bite out of the Big Apple, one of my favorite cities, Jody, New York City. New York City. Today's broadcast is being shown, I believe, in Times Square on the Toshiba Vision screen, so the city can also enjoy the spectacular views of today's total eclipse. And we've got a great relationship with Toshiba, so a shout out to you guys. This Midtown Manhattan tourist location is always bustling with crowds. On the average day, over 300,000 people pass through Times Square. Alex, I'm gonna turn to you. You know, New York, they're gonna get a partial, but they have a rich history in solar eclipse.
They really do. So actually 92 years ago, on a cold January morning, New York City, Manhattan, and Queens experienced a total solar eclipse. The edge of the Path of Totality went from 95th Street to 97th Street. This was an amazing opportunity. This was the first time we sent up 2 dirigibles with the U.S. Naval Service for scientists to study this. At the time, we actually thought eclipses could be creating radio waves which mess with communication. But what in fact is happening is the sun itself is creating this disturbance. So studying the eclipse is actually telling us about the sun, which is creating these disturbances here on Earth.
Yes.
Okay, so this just in. I believe we have results from an experiment that occurred on NASA's Gulfstream 3 aircraft from NASA's Armstrong Flight Research Center. Karen Rohr is standing by with Thomas Zabukan, the Research Administrator for the NASA Science Mission Directorate. Let's go now to see what the instrument observed during the total solar eclipse. Kevin.
And we're back here at the G3 up over the Pacific Ocean off the coast of Oregon. And it was amazing, wasn't it?
It was outstanding.
And so for me, like, you know, at 25 years, I did research on the corona. I saw it for the first time. It was my first eclipse. Was it your first eclipse?
My first eclipse as well.
Just absolutely amazing. And I want to talk about two things. First of all, the shape of the corona. You know, I saw the models, I showed the model, and it was remarkably similar. You know, I saw these streamers, these magnetic structures coming out like glows in specific directions, just like we expected. So I'll look for the analysis before we claim victory, of course. But the other one is that spectrograph you, Mike, you know, ran on board. And just before that the sun, you know, disappeared behind the moon, that spectrograph, of course, is spreading out the light in all its colors. Just before it disappeared, there is that one shot. And Laurie, I want to ask you whether you could turn it on. Do you see those specific kind of lines that pop up between the green and the red? It's just like we said, it's helium. Remember, that's how it was discovered, helium. We didn't know we had helium here. It was a new element. It was discovered that way. And then over there in the red, between the green and the red, is iron. Iron, a really hot iron, telling us that, hey, this atmosphere is really hot. And then a little bit over, it's another line, red. Well, what is that? Well, it's hydrogen. Well, so even though it's really hot up there and only 1 in a million or 10 of million particles are neutral, it's still visible in that one shot that you saw. So Robert, back to you here, back on Earth. What did you feel like? How did you see this occur?
Yeah, so it was fascinating to watch actually the shadow or the path of totality underneath us. We're at 35,000 feet, and you could see at totality, you could actually see the darkness down on the ground. And you could look north and south and see where it wasn't completely dark. And as we kept going, you could just watch that darkness move. It was almost like a thunderstorm moving across the plains, but it was all the darkness, and it was just stunning to me to see that. So really, really good stuff, and I wasn't expecting that. And of course, the eclipse itself was beautiful, but seeing what happened down on the ground level of Earth from 35,000 feet was amazing. I just got to tell you, the team on this plane and the team all the way around this country is just doing a fantastic job. I wish you could have seen the folks here working to make sure we got the data that Thomas showed, some fantastic images we've already looked at that I can't wait to share with everybody and for everybody to see. But really exciting to watch this team work, and the pilots did a great job. We had a little bit of a challenge right at the time of when we needed to be best, but they did a great job recovering from that, and then kept us on path all the way through. So anyway, so thank you guys. Remember to put your glasses on for those of you who hadn't seen it yet, and we'll talk to you soon.
Fantastic stuff. And if you just tuned in here, you're watching Through the Eyes of NASA, NASA television. We have the best views of the solar eclipse today and coming later in the show. You don't want to miss this, the International Space Station live. Now, next up, let's visit a working farm at Austin Peay State University in Clarksville, Tennessee. Agricultural observations and solar eclipse viewing activities are underway, including high-altitude balloon launches and painting cows.
Painting cows? What?
Okay, all right. So now let's go to the NASA Marshall Space Flight Center. Chris Blair standing by.
Humans are naturally excited about the solar eclipse, but one thing we've learned on this working agricultural farm is that animals can as well. But more on that in a moment, as right now we're getting ready to do a live scientific balloon launch. And joining us to tell us more is Dominic Critchlow from Austin Peay State University. Thanks for joining us. We appreciate it. So tell the crowd and our audience a little bit about the scientific payload you have on board.
Yeah, thank you for having me. Today we're flying some still image equipment, and we're going to be taking images of the ground in different wavelengths. And we're also flying live streaming equipment, so we can live stream the eclipse looking downwards and looking around, and at 100,000 feet, which is higher than any plane has ever gone. We're also flying some biological samples with NASA Ames, and then our trackers so we can have a successful recovery.
Okay, and they've just released your balloon, so let's talk about the NASA science and the biological samples. Explain more.
So NASA Ames has contacted us and all of the other teams that are going to be doing launches today across the whole path of the eclipse. We're going to all have a little chip of biological samples on there that are going to go up in the stratosphere, which is a similar atmosphere as we would see on the Martian surface. So we're doing some Martian studies, which is really interesting and cool.
We are very excited about that. And so also, how many balloon releases are you planning on doing this today or this weekend?
So all across the U.S., we have about 50 teams that are launching in the path of the eclipse so that we can have a full coverage of the stream. And on the site today, we have 3 launches from 3 different universities, and we're just really excited to be here, and hopefully all successful launches.
All right, so finally, these balloons do go up and they come back down. And so what's some advice if anyone finds one of these payloads out and about across the country? What's a tip you would tell them?
If you find it, leave it there. Maybe take a picture, because it's kind of cool to see something land in your backyard from research. And please don't touch it. We'll be there soon to pick it up. If you have to move it, let us know, and we'll just be there to recover it.
Awesome. Thanks. We appreciate your time.
Thank you.
Appreciate it. Okay, so yesterday we had a chance to catch up with some serious students, albeit a little younger, but serious about doing real-world science nonetheless. And here to tell us more is my good friend and colleague, Mitzi Adams from NASA's Marshall Space Flight Center in Huntsville, Alabama. Mitzi, thanks for joining us. We appreciate it. So tell us about the science that these high school students are working on.
Well, the students are actually working on some atmospheric science experiments. They're doing animal study experiments, and they're helping us observe the sun in various wavelengths of light.
And these students aren't just from the Clarksville area. I understand they're all around the country, if not perhaps the globe.
The students are from the U.S. Space and Rocket Center, and yes, they are from all around the globe. And they're actually from the INSPIRE project as well. They're participating in VLF radio noise experiments, and those folks are from Washington, D.C.
All right, excellent. And so you mentioned the Space and Rocket Center, Space Camp. That's the official visitor center for NASA's Marshall Space Flight Center. Feel free, if you're in northern Alabama, to come and see us. They do a great job of representing a past, future, and present history of NASA. So any parting words?
Well, you know, in the words of Frank Reynolds, I'd like for us to remember for the next American eclipse in 2024, let the shadow of the moon fall on an earth at peace.
Very poetically done. We appreciate it. All right, so up next is, as promised, our Animal Lovers segment. And so here on the agricultural farm, students are studying a really cool STEM field. So it's conservation management, it's veterinary medicine, animal biology, and so they're interested in animal behavior. And so joining us is Dr. Donald Sudbrink, head of the Ag Department here at Austin Peay State University. And so it's not cow tipping, it's cow painting, correct?
Yes. We had to paint the cows that are in this study to see what sort of things that they would do, so we could record the individual animals so we could see what behaviors that they were exhibiting.
So we saw the cows, and the students were involved with that Mitzi just spoke about. And we're also talking about cricket behavior and cricket observations.
Yeah. Yes. Well, we're also talking about crickets. I'm an entomologist by training, and crickets generally chirp at night. So we're going to get a chance to see a series of isolated males and see what they do when the sun goes out.
Okay, excellent. Well, glad you all are doing this kind of observational research. Really appreciate your time.
Thank you.
Thanks a lot. So, and speaking of time, it's almost time for us, everyone here at Austin Peay State University, to actually watch the solar eclipse. So let's go back live for continuing coverage of NASA's eclipse across America from Charleston.
Okay, so Yadi, I wonder if the milk tastes better when you paint the cows. I don't know.
I don't think so. I don't think so.
All right, let's go to social media. We've been in the show here, and I know it's a buzz. So over to John Yerbrick for social media update.
Yeah, last time I looked, Dwayne, there were 2.1 million people looking online on our website, on our 1.2 on our live stream. So it's a huge conversation, and Solar Eclipse 2017 is still trending #1 on Twitter. So it's been huge. Can we go to the first slide here that I've got up? This right here is an amazing photo. Sometimes they say you have to be at the right place at the right time. This is taken by one of our NASA photographers, Bill Ingalls, out in Washington. And he captured, it's hard to see here in this pic, but he captured the International Space Station transiting the sun during the partial eclipse there in Washington. Pretty amazing. You kind of have to look closely. We'll also be putting these images up online if you want to see them. But one of those little dots there is the International Space Station traveling at 17,500 miles per hour. Here's another one from our photographer in Wyoming. Same concept, capture the space station. We knew exactly when the space station was going to be flying, what its orbit was, and when it was going to cross the sun. And look here, it's just an amazing sight. I'm really proud of our photographers for getting these shots and proactively trying to get something that no one else probably has, and thinking through and getting this great image. So let's take a few questions from social media. I want to remind our viewers at home that you can ask questions to us here on the set and on social media with the hashtag Eclipse 2017. So why don't we bring it back here to the stage. First question is from Twitter. What if we wear sunglasses instead of eclipse glasses? Will we actually be able to see the eclipse? Do sunglasses help? Does it give you any sort of protection?
No, that's definitely a no-no. You should not wear sunglasses, normal sunglasses. Always wear the actual sunglasses that are made for solar viewing, like the ones that I'm having here right now in my hand. And if you don't have the sunglasses, you never look directly at the sun. You look like you do an indirect projection of that eclipse. Never look at the sun without the proper safety.
So another question here comes from Deborah from Facebook. So the sun rises in the east and sets in the west, and the Earth rotates in clockwise motion. Please explain how it starts in the west and ends in the east.
Well, so the Earth is rotating from west to east, but actually the moon is moving faster, about 3,400 miles an hour, casting a shadow down on the Earth, which is rotating about 1,700 miles an hour. And that actually means that the shadow is moving from west to east across the Earth at about somewhere between 1,200 to 1,800 miles per hour, depending on where you are on the Earth.
Okay, great. We have another one. I think we have time for another one. Tina from Facebook's asked, if I place a lens from the eclipse viewing glasses over a viewfinder on my iPad, could I successfully video the eclipse, or would it fry my camera?
Yeah, you can actually look with the iPad or your phone to the eclipse. The only thing is, you have to be very careful not to look at it with your own eyes without the actual safety glasses. Never look at it through any lens.
Okay. This is Mickey from Facebook. Hey, NASA, can the International Space Station see the shadow of the moon crossing America from space? Do they have that view when they're looking from space?
They do, and that's what we're hoping to see from them, yes.
Excellent. So, John, we're going to come back to you. So I think we're going to go back to Sean, our meteorologist. Let's learn more about how NASA is studying the Earth and Sun relationship during this eclipse. Sean, can you tell us more about that?
Right, thanks, Dwayne. So during the eclipse, the moon acts like a giant cloud as it passes over areas in the path of totality, casting a large shadow on Earth's surface. Now, the footage you're seeing right now shows a solar eclipse that occurred in March of 2016 over Indonesia. That experience helped us determine how best to study today's eclipse. These images were taken by NASA's EPIC instrument aboard NOAA's Deep Space Climate Observatory, or DISCOVER. It's just one of the instruments we'll be using today to study the eclipse as we monitor changes in Earth's energy balance. Scientists have made extensive atmospheric measurements during eclipses before, but this is the first opportunity to collect coordinated data from both the ground and from a spacecraft that observes the entire sunlit Earth during an eclipse. Dwayne, back to you.
Thank you, Sean. Okay, so now we have a special guest with us today, the Associate Administrator for NASA's Office of Communication, Jinray Wong. Jinray, welcome.
Dwayne, thank you. So happy to be here.
Oh, it's an exciting day.
It's a
I'm
wonderful
glad you're
day.
to join the team here. And our next location you are pretty familiar with, I'm sure.
I'm very blessed, and I do know something about the great state of Nebraska. I've actually lived there for the last decade. And I have friends and family who are watching there from the Path of Totality. I have to tell you, this is by far the biggest thing that's happened in Nebraska as of recent. It's absolutely fabulous. I have had friends from high school and college calling me up, Facebook messaging me, asking where they can get their glasses, where they should be viewing from. So it's just a really exciting day for everyone who's watching along the Path of Totality. It's also a really exciting day for NASA. And in fact, this gives us an opportunity to look forward as well. And we have a future study that we are going to be doing for to study the sun. NASA is going to launch a new spacecraft next year, the Parker Solar Probe, and it will fly directly into the solar atmosphere. The mission will provide first of its kind data. And for more information on this future mission, let's go to Beatrice, Nebraska, where Vince Whitfield from NASA's Langley Research Center is standing by. He's at Homestead National Monument, where the National Park Service has coordinated an eclipse viewing. Vince?
And just in, I think we're having, Vince is going to come up shortly, Jinray, so we're going to go back with an image, but we will be doing Nebraska as soon as we can. So a shout out to the great state.
Thank you.
Okay, folks, Jadi and Alex, this is a different view here. What are we seeing, Alex?
Well, so we're looking at a different wavelength of visible light. It's called calcium K. So this is light that's produced by excited calcium. And this is showing us the sun as the moon is moving over it. And in fact, if you look over to the left, on the edge of the sun, you actually see sunspots.
A sunspot, yeah.
And these are regions that heliophysicists like myself and Jari are most interested in, because that's where solar explosions originate from. In fact, the magnetic fields that come up into the corona that we see during the total solar eclipse originate from those sunspots.
Yeah. Actually, this sunspot had a solar flare yesterday.
Right, and I believe this is coming from Carbondale. So that's now it's why is it purple? Is that what's the color?
That's actually the light and the color of the light in the filter. The color is a bluish light, and so it comes out as a purple color. But it is a type of visible light. It's one we look at quite often from both space and the ground and look in the sun.
Now I see some black thingies, look like a little river. You see it over there near the corner on the left?
Yeah, that's the sunspots.
Now, what's a sunspot, just for our audience here?
Those are the regions where most of the space weather actually originates. The solar flares, the coronal mass ejections, are regions of the sun that have very complicated magnetic fields. And these are where most of the magnetic energy is actually released.
Right, so those are regions of super intense magnetic field, 1,000 times stronger than the Earth's magnetic field. And those have lots of energy and they drive space weather.
Okay, I think that's why we didn't get the Nebraska feed right now. Those things cause that, I think, right?
That's right. We're getting a little glitch.
Hopefully we get Nebraska. Okay, Sean, we're going back over to you. We'll talk about moon shattering.
That's right, Dwayne. We've got some really incredible imagery for you. This is again from the GOES-16 weather satellite, just launched last year by NASA for our friends at NOAA. And what you're seeing in the western portion of this image is actually the moon's shadow being cast over parts of the path of totality. And of course, you see the cloud cover across the U.S. as well. And as I was telling you earlier, it's actually looking pretty good for most of the western parts of the U.S. that are in the path of totality. Not so good for maybe parts of the central U.S. Where we've got some thunderstorm activity developing and expected to develop later today, this afternoon, for places like Nebraska, parts of Nebraska and Missouri and northern Illinois, so maybe north of Carbondale, and then gets better again as you see in terms of cloud cover as we move further east toward Charleston here. But here in Charleston, we still have some breaks in the cloud. Where the sun is, it's still obscured, but we are able to actually see some of the partial eclipse here in Charleston through some of the breaks in cloud. But again, really wanted to show you guys that imagery from GOES-16 satellite from NOAA showing you the moon's shadow actually being cast over parts of the western United States right now. With that, Dwayne, I'm going to hand it back over to you.
Thanks, Sean. Now, as a reminder, our broadcast is tracking the total solar eclipse as it crosses the United States. It's moving along a path of totality. That's a 70-mile wide path sweeping across the entire nation. Over 12 million people live inside the path of totality, plus it's estimated that close to 7 million people have traveled to cities within the path of totality. I know that today is truly a day of celebration as people gather in cities and festivals to view today's celestial event. So let's get into the cultural impact here, guys. Alex, what's your take on the cultural impact of these eclipses?
Well, you know, this is really such a fantastic opportunity to connect the nation and, in fact, the world with one of nature's most amazing celestial events. And this is something that we, as working at NASA, are really excited to be able to share. And in fact, we've even worked with some of our colleagues in other parts like the U.S. Postal Service.
Yes, the U.S. Postal Service actually created a special stamp for this event.
Right. So what I want to do, let's talk about the stamp.
Sure.
But Jen Ray Tossin, Nebraska, the sunspots are gone, so let's go to Nebraska. Vince Whitfield, are you there?
Hi, we're at the Homestead National Monument of America. This is a great location to watch the eclipse, and we've staked out a good spot here on the prairie. Even though the weather isn't cooperating, this is still an excellent event. We're also very prepared. Please make sure to use your protective glasses when viewing the eclipse wherever you are. You can cause serious damage to your eyes if you don't take precautions while watching. And there are a lot of people watching. As you can tell, The festivities, just like the eclipse, are in full swing. I'm joined by Chief Park Ranger Susan Cook.
Hey Vince, how are you?
Great, Susan. Thanks for joining me today. Please tell us about this amazing place and what's going on behind us.
Well, we are at Homestead National Monument of America. We are a national park site dedicated to telling the story of homesteading. 30 states, 4 million people, 10% of the United States was homesteaded. The head of a household, anybody could own land as long as you could be a U.S. citizen. You got 160 acres. It's how we settled the West. We built our democracy, we built our economy, settling the West through this law.
That is just so interesting. Now, I understand the Mayan calendar followed the solar eclipse calendar closely. Is that correct?
It did. The ancient Mayan used several different calendars to organize their secular and spiritual lives. Many of these calendars had strong roots in the motions of celestial objects, especially the sun and the moon. And the Hab calendar is a solar calendar of 365 days, subdivided into 18 months of 20 days, plus 1 month of 5 days. Another calendar is a Tzolk'in, made of 260 days, subdivided into 13 months of 20 days. This calendar also has a resonance with eclipses, which occur about every 173 days. Every 3 sequences of eclipses aligns every 2 cycles of the Tzolk'in. Who could keep track of that, frankly?
It's just amazing. Now, as a Chief Park Ranger, I have to congratulate you. This is a fantastic venue. Tell us about some of the activities you have planned.
Well, actually, right now you can feel it getting darker, but we have stage performances going on. We have many NASA scientists. You can learn about planetary defense, how do we defend our world. You have NASA scientists doing other things. We have Native Americans. We have a Mayan Calendar in the Sky program. We have folk music. We have all sorts of fiddle music.
Lots going on.
Lots of things, balloon launches. So there's things all around us. It's really exciting and a lot of fun.
Got to say, the amount going on here, Susan, is incredible. Thank you so much.
Thank you very much. Thanks for being here.
Absolutely. And we're lucky enough to be joined by a real NASA scientist. Let me introduce you to Dr. Nikki Fox.
Hi Vince, how are you today?
Great, Nikki. Thanks for joining us. Nikki is a space weather expert and a mission project scientist on NASA's Parker Solar Probe program. Thanks so much for joining us, Nikki. Today is a great day for you. Tell us why.
Well, today I'm really excited. This is my first ever solar eclipse, and it's the only chance that we can see the corona with our naked eye. And I'm particularly excited because I'm working on NASA's Parker Solar Probe mission, and we are going to fly into the corona. So if the clouds part here, you'll be able to see where our mission is flying.
That's just incredible. Now, how close will you get to the sun?
We will get to within 4 million miles, and I know that doesn't sound terribly close, but if I put the Earth and the sun apart on a football field, then we would be at the 4-yard line.
That's just amazing. Now, for you watching at home, that's kind of like traveling from Washington, D.C. to Philadelphia in about 1 second. Just incredible speeds. Now, how can you be so close to the sun and not burn up?
So we have a wonderful heat shield, but we also, the technology, it's been 60 years since this mission was first thought of, and it's only now that technology has caught up with our dreams.
That's just amazing. Now, it looks like we're coming up to the moment of totality here on the prairie. What are some of the things we should be looking for?
So if it clears, you should see a beautiful corona, and that it looks like a pearly, hazy crown around the sun. And in fact, it's called a corona because that's Latin for crown. And then as it's going beautifully dark here, it's becoming twilight. You hear everyone going crazy here. You should be able to start seeing stars, and we can actually see 4 planets. This time you should see Jupiter, Mercury, Mars, and Venus all in this night sky during the day. So it's just an amazing, amazing experience. And if you can't see the corona, I do have a map of it here. This is a 3D print that was done for me, and it looks exactly, it's a predict of what the corona looks like today. So if it's cloudy, here's your corona.
Now, it looks like the moment of totality is upon us. Let's just let the guys at home have a few moments to take in the sights and sounds of the crowd as totality happens on the prairie.
Oh, wow. And you can see the corona, and I may cry, but you can see the corona. So now you're seeing this wonderful hazy atmosphere. I don't need my glasses now, Vince, because we are in totality.
Wow.
And so this is the only time that it's safe to look. but right now you can see that hazy ring. That is the chromosphere. It is looking a little bit sort of reddish, and you just see there's those red wisps are little prominences that are coming away from the sun.
Wow.
Unfortunately, we can't quite see the stars yet because of the clouds, but my goodness, you can see the corona, and that is an absolutely incredible, incredible sight.
Yeah, this is just magnificent.
It really is. Everything's kind of, well, other than the people hooting and hollering here, everything else has gone quiet. The animals think it's nighttime. There's this amazing sort of twilight view all around us. And just look at that corona. That is incredible. Absolutely incredible.
Yeah, that's amazing.
Yep, and the moon is going to continue. We've got about 2 minutes, 35 seconds of this amazing view. And then here we come. Here comes the diamond ring. So it is glasses on again time. Glasses on. And here it comes. There's the diamond ring. And that is the most spectacular sight.
That's amazing.
That is just incredible. And of course the diamond ring you see because the moon is not a totally smooth sphere. And so you're seeing little spots of light peeping out between the craters on the moon. And my goodness, I'm sorry, I'm so excited. It's incredible.
Yeah, it's hard to convey the excitement of the energy. There are 10,000 people on the prairie here at the Homestead National Monument of America, and the energy is just amazing.
And they've been here, a lot of them have been here since 6 o'clock this morning, and the atmosphere has been incredible. Everybody is happy, and it has just been amazing.
That's just amazing.
Wow.
Okay, Nikki, let's bring you over to this side. It looks like the moment of totality has passed us here.
Yes.
Now, what should we be watching for in the moments after totality?
In the moments after totality, you will start to see again the Bailey's beads. So we did see that diamond ring, and I got super excited. But as the moon continues now to pass away, you'll start to see the solar surface come back. It's becoming light again. If we had any roosters here, they would actually be crowing. So it's just been, it's amazing, and you'll start to see the sun coming back. And I don't know, I always think what it would have been like if you didn't know the sun was going to come back. You just thought it was disappearing, but here comes the sun again. So it's a wonderful, wonderful day here on the prairie.
That's wonderful. Nikki, what an amazing experience.
Yes.
Thanks so much for talking us through that.
I wouldn't be anywhere else, Vince. Thank you.
Thank you very much. What a great experience, everybody. That is amazing. Now, it looks like things are starting to calm down here on the prairie, but that doesn't mean the show is over. Our coverage of the Path of Totality continues across the entire path. So, let's go ahead and send it back to NASA's Eclipse Central.
Thank you, Vince. It was well worth the wait, my friend. We were a little delayed there, but my goodness. Jody, did you see that? I mean...
That was amazing. Do you see that diamond ring?
That was, it was even more prominent there.
It was very prominent. You could see like the ray of light, like very, very nice, and the whole diamond around the whole surface. It was amazing.
And Alex, it got really dark. I mean...
It really did. That's actually enjoyed seeing them out on that prairie and seeing... It looked like she was in some sort of weird, strange light, and she was lit up, and everything behind her was dark. It was really cool.
Fantastic. Nebraska, you rocking the house. We really, really appreciate that. But like Vince said, there's a lot more to come, and we got the International Space Station, so don't forget. So, Jody, I want to go back. We had to bring in those images, but we were talking about, and you mentioned the stamp. Now, the United States Post Service, they do amazing work.
They do.
But they really outdid themselves this time. Go ahead and finish.
They did. They actually created a special stamp for this event. It's actually a thermochromic stamp, which means that it gets activated by heat, and you're actually looking at it now in your images. This stamp, if you put your thumb into the center, it will actually make the moon surface appear, or any type of heat that you apply to it. It's an amazing stamp, and I got mine yesterday thanks to Dwayne.
And it's thermochromic?
Thermochromic, yes.
Yes. Oh, wow.
It means it gets activated by the heat.
Yeah, heat of your thumb, and I bet you they sold a lot of those stamps.
Oh, they did. They sold out online originally right away. So it was quite a popular one. It's the first time the U.S. has ever used that type of ink.
Okay, so we have seen some pretty cool images. Still got some more to come.
Yeah.
The diamond has been prominent. Let's go over to social and see how things are going. John.
Thanks, Dwayne. We're continuing to look up here in Charleston, South Carolina, because there are some clouds here, and we're excited. Excitement we want to have here too as well. Just a couple quick interesting things. This is the biggest live stream event ever measured on NASA.gov. The web traffic is accounting for 87% of all federal web traffic, which is pretty amazing, showing that people are really, really tuning into our broadcast here. As of 1:40 p.m., 4.4 million people in climbing were watching this broadcast. So the interest across the country is obvious here, and we're going to continue to show you some amazing live views. This right here is, again, another photo of the space station taken by Bill Ingalls in Washington, one of our photographers here at NASA. Next thing, I have a video from another photographer, one of our other photographers, as the space station transits. You can see it there. If you're looking closely, you can see the space station transiting the sun during the partial eclipse. Pretty spectacular. Again, that's 250 miles per hour, that space station. You have to be, 250 miles above the Earth, 17,500 miles per hour. You have to be taking a lot of different shots pretty fast to capture that. So nice job, Joel.
Okay, so let's go to Jefferson City. The moon shadow is continuing to pass over the United States in this remarkable celestial event. Our next stop on the path, as I said, of totality is Jefferson City, Missouri. We're going to hand off to meteorologist Eric Aldrich, who is a professor in atmospheric science at the University of Missouri. He has some special guests to help explain 2 important impacts solar activity can have on humans and the technologies we use. Over to you, Eric.
Okay, thanks a lot. Yeah, we are live in Jefferson City, Missouri. Jefferson City is actually the state capital, and as you can see behind me, there's a lot of people that are here. It's been a whole weekend type of thing, Saturday, Sunday, and of course here on Monday, lots of family-friendly things. There's been corn mazes, there's been 5K runs, there's a lot of good food. Too bad you can't smell the food, but there's a lot of good food that's here as well, and just a very nice weekend. The weather has been perfect. We've had some showers and thunderstorms off to the west all morning. We've had a few high clouds kind of stream on in, but certainly things are looking really good. I am lucky to be joined here by 2 special people that are going to be talking about space, weather, and just how things work in space. Dr. Janet Kavandi, thank you so much. You are the director of the NASA Glenn Research Center in Cleveland.
Right.
You're also a 3-time shuttle astronaut.
That's right.
And you are actually from Springfield, Missouri.
I
so
am.
Welcome home.
Thank you. It's great to be back.
Well, great.
Yeah.
So now, we've been talking a lot about safety, and obviously you don't want to look right up at the sun.
Not without these.
That's right.
You're right.
And so we all have some, so that's good. But what about the astronauts that are up in space? What is there to help keep the astronauts safe from the solar radiation and so on and so forth?
Well, for their eyes, we know that they know that certain windows they should not look out of because there's no protection. Other windows have protection on them that help shield their eyes, but also there's other kinds of radiation like protons that come from the sun, heavier particles that can cause damage to our cells, and we try to shield the astronauts as best we can because they're above the atmosphere. We're shielded here by the atmosphere quite a bit, but above that you don't have that natural shielding, so we have to do it with metal in the vehicle, and then some water bags around the sleep station so that they can sleep surrounded by water, and that also helps absorb some of that radiation.
Okay. Now, we also are kind of excited about space communications, and that's certainly another special research area. And so also with me here today is Dr. Tamitha Skov. Now, you're from the Aerospace Corporation in Los Angeles, so welcome to Central Missouri.
Thank you.
Now, you're also a space meteorologist, and you are also referred to as the space weather woman.
I am.
Right? So I've been intrigued by this. What exactly does a space weather woman do?
Well, most people don't realize that the sun actually has its own unique weather that comes from it. And those solar eruptions that come from the sun, they actually hit Earth and cause issues for us. So I actually do a weekly broadcast, weather predictions, just like you do, like a meteorologist, that talks about when these events hit Earth and the types of issues that they cause for things like communications, like GPS and other systems.
Okay, now we're just about 15 seconds away, actually, I believe, from Totality.
Put our glasses on.
So we're going to put our glasses on. You can hear the crowd cheering in the background, and it is getting dark.
We're getting close to Bailey Beads. Here we go. We're almost at Totality.
And
you can see
here
the
we go.
There's almost the diamond ring right there. And there we go. I think we're at Totality. So now you can take your glasses off.
That is amazing.
Listen to that. You can actually see the corona a little bit even through the clouds.
That is incredible. Now, Dr. Kavandi, you've been in space. You've seen numerous sunrises and sunsets from the space shuttle. How does this event compare?
Oh, this is completely different than anything I've seen before. I never saw an eclipse. I've seen a partial, but nothing like this. This is really unique and nothing like I saw in space. Space has its really cool visuals, but This is really amazing.
You know, and I'm starting to hear the crickets. They're starting to come on out. Obviously, the street lamps. This is just amazing. Now, I'm also looking up to try to find the Big Dipper and some of the other stars, some of the other planets.
Not through the clouds, likely.
Right.
And I'm like I'm really mesmerized by this. This is a spectacular event. We've had several solar storms that have been launched, and some of them have been launched from the left side of the sun. So we're actually seeing a difference from what the corona looked like in our predictions to what it looks like now. And then on top of that, we have ham radio operators all over the state right now who are making contacts that they haven't been able to make because the upper atmosphere is just all turbulent right now, and it affects the communication signals. So we've got GPS operators and ham radio operators doing a ton of science, and it's just so overwhelming.
This is amazing. Now, my team of atmospheric science researchers from the University of Missouri, they are actually sending up weather balloons here this afternoon to try to figure out, how the weather is changing at certain height levels. And actually, here's a map of the solar radiation throughout the state of Missouri, and you can kind of see how much solar radiation is hitting the surface of the Earth here in Missouri. Just interesting. This is amazing.
It is. You can tell the crowd is just mesmerized. This is so cool. And you can even see the dips in the valleys, as you can see little areas of the sun where it's shining through more.
Right, and those create the Bailey beads that we'll see as we get out of totality, which is coming up here pretty soon.
Right.
Not quite yet, though.
Yeah, I think we come out of totality at 1:15:35 local time, and so we just have a few more seconds of that. Absolutely an amazing event. And again, we're so lucky that some of these high clouds were able to kind of
fall apart.
Kind of fall apart a little bit so we could experience this.
For us, yes. And I can't believe we can actually see the corona through the clouds.
Great.
Okay, that's the air horn. We're coming out of totality. We're going to have to end up.
So we need to put our safety
in just
glasses back on.
There we go. Put your Bailey beads. There we go. We got to put the glasses back on. Oh my goodness.
So as you can see, we're coming out of totality here in Jefferson City, Missouri. Ladies, thank you so much for experiencing this with me.
Thank you. Quite an experience. Thank you very much.
Yes, it was. Thank you. So everyone's excited here in Jefferson City, Missouri. The sun's starting to come out a little bit. We're going to go ahead and send it back to Charleston.
We should have stayed.
Thanks, Eric. Yadi, wow.
It's an amazing, I get goosebumps every time I see this. So I cannot imagine how it's going to be, when we actually see it here in South Carolina.
I mean, so Alex, I'm speechless, man. I mean, as a scientist, you gotta love this stuff, right?
Oh my God, and it's so great to hear them. I mean, I love hearing an experienced astronaut talk about how overwhelming it is, given the amazing things that she has seen, but also to hear my colleague, Tamitha Skov, who is also a heliophysicist and a space weather expert. I can hear the excitement in her voice. I mean, it's palpable. It's just great.
Okay, so check this out, guys. I mean, I think things are going so smooth. We're gonna go to another image right now from Hopkins Girl. Brian Massey, out there from Marshall Space Flight Center. What's going on? You got some action there. Hopkinsville. There it is.
That's beautiful. They're getting close.
Now, it's yellow. Is that, we had purple, does that mean something there?
Well, the previous one we saw that was purple was calcium K. It was a blue kind of light. This is actually more of a white light, continuous. Yeah. But the thing to remember is sometimes the different filters you use will change the color just a little bit. But what we're seeing here is really more visible, broader spectrum white light.
Okay. White light.
Let me, John, you gotta have some cool stuff on social media.
This is a good question, guys. Mark from Facebook's asking, and this is what really applies right now. When observing the moon at night, I see it proceed from eastern to western horizon, much like the sun does. How come the solar eclipse is traveling from west to east across the U.S.?
Well, again, that's because when we're looking at the moonrise, that's actually because of our location on the Earth and the fact that the Earth is rotating from west to east, the same reason that the sun rises in the east and sets in the west. But the moon itself is moving in the same direction the Earth is rotating, and it's casting that shadow down on the Earth, and that is moving in the direction that both the moon is orbiting and the Earth is rotating. So from west to east.
Okay, so the total eclipse has now passed over half the country. It's currently over Illinois, and I think we're going to have some views coming up shortly. But what I really want to do here, guys, is this has been really incredible. I want to give a shout out to the College of Charleston. Make some noise. Oh, we're loving it here. So now we've got live video coming to us from Hopkinsville, Kentucky. It's a small town that's known for southern hospitality, like Charleston, and it's also a prime spot for viewing this total solar eclipse. Hopkinsville is the city with the longest duration of the total solar eclipse, for a total of 2 minutes and 40 seconds of totality. NASA's Marshall Space Flight Center, Brian Massey, I'm so excited. What you got, man?
Dwayne, we're just as excited as you are. We are here in Eclipseville. Say hello, everybody. Oh, we're having a great time. I'm surrounded by 1,000 of my best friends. We're getting ready. It's starting to get a little darker already. We're also joined here by NASA Marshall planetary scientist Renee Weber. Renee, thanks for joining us.
Thanks. It's really great to be here. I just want to say thank you to the city of Hopkinsville for having us out on this beautiful farm in Kentucky, and we're just all really excited.
Yeah, definitely. It's a lot of fun. The light's starting to fade, and the excitement's getting bigger. We are at the point of greatest eclipse here at Hopkinsville. Renee, tell us a little bit, what's the significance of that?
Well, the point of greatest eclipse is actually a point in time when the axis of the moon's shadow is pointed most directly towards the center of the Earth.
Great.
So we are at the point on the surface of the Earth where that time occurs.
Exactly. The shadow will actually be more circular here than anywhere else in the country, correct?
That's right. And it's getting really dim, and we are just so close. It's incredible.
Yeah, this is amazing. We can't wait to break out in the darkness. We've got our glasses out. We've been looking up at it. You can see now on the screen our live telescope view, and this is just amazing. Everybody is really enjoying it. We've got people from all over Kentucky, people from all over the world have joined us here, as this is Eclipseville, USA, and we are just a few minutes away from total totality. But before we get to that point, Renee, tell us, you're a planetary scientist and you specialize in the moon, a lunar scientist. How does the eclipse really speak to what you do?
Well, it is pretty cool to look up there, and when you're seeing that sun get dimmer and dimmer, it's because the moon is up there. Right. And I like to tell everyone that you're really looking at the moon when you're watching a solar eclipse, and it's just getting dim, and it's starting to get a lot cooler too. Yeah, it's incredible.
Crazy. This is my first solar eclipse. Renee, have you ever experienced one?
This is my first total eclipse too. I've seen partial eclipses, but I've never had a chance to see totality before, and I'm just so excited.
It's amazing. The light is starting to fade as the moon steps in front of the sun here, and it's already just a really eerie feeling here, getting dark in the middle of the day. But we're really excited about it, and we're just a few seconds away. I've lost my counter, but I'm going to look back at the sun while I still have the opportunity. Wow, that is absolutely amazing. We're down to just a thin sliver of the sun. Renee, what do you think about this?
I can't believe it. It's just, it looks incredible, and it really is starting to get dim, and nobody even needs their sunglasses, just your eclipse glasses, and you can see that beautiful crescent sun.
Wow, this is absolutely amazing.
We're just really looking forward to that for a chance. We got no clouds here in the sky, and you can see some airplanes up there, but that sun is just getting smaller and smaller.
Yeah, it's definitely a Hopkinsville, Kentucky Chamber of Commerce sponsored day here in Eclipseville. There's not a cloud in the sky, and it's amazing how it's gotten so much cooler here since the sun started covering up started being covered.
Yeah, it's nice to have a break from that hot southern sun.
Yeah, definitely. We've been sweating it out a couple days here in Hopkinsville getting ready for this.
We're getting really close now.
So what exactly are we looking at here, Renee?
Well, we're just about close to 100%. It's just getting smaller and smaller, and it's getting dimmer and dimmer, and hopefully soon we'll have a chance to see those Bailey's beads and that diamond ring. Right. That's when you can actually see the light shining through the moon's valleys. And the moon's not a perfectly smooth sphere. It's got that rugged surface, and you can see those sun rays shining through those mountains and valleys and craters.
Wow.
It's looking like we're about 1 minute out now, and it's just getting smaller and smaller.
Wow, this is amazing.
The crowd's getting really excited too.
Hey guys, who back there is excited for the solar eclipse? Wow, it's getting closer.
Wow. It's just getting really close to nighttime. It's incredible. It's like very dim.
Definitely it feels like dawn or dusk here in Hopkinsville right now as it's getting closer.
Come on! And you can see on our feed, there's that tiny, tiny little sliver left to go. And it's really starting to get dark now. Wow. It's like
Goodness
dusk.
gracious.
And you can see the pink color around the horizon. Oh, it's like a sunset. It's beautiful. It's going. It's going. Just that tiny, tiny last sliver. Oh my goodness.
And we are in total solar eclipse, and this is absolutely breathtaking.
Yeah, you can see the corona, that beautiful white wispy crown coming out from the sun in all directions. And we can see airplanes, and I think I see Jupiter in the sky over there. I think I can see Jupiter.
Wow.
And I see other planets too, and stars.
I can only imagine in ancient times what this must have been like.
I know.
Out of nowhere. I am covered in head to toe in goosebumps. A complete chill.
I know, I am too.
Body.
I just can't believe we finally got a chance to see it. I mean, it's one thing to read about it, but it's another thing when you get to see it yourself with your own eyes.
Guys, we're going to take a break here just a second. We're going to step back and fully enjoy this and hope you enjoy our feed on the telescope. Eclipseville. It has definitely lived up to
And now we're getting that diamond
Here we
ring
go.
on the
We've
way
got it
out.
coming back. The moon is stepping aside
And
from the
now
sun. It is getting
Totality's over.
brighter. Totality has finished here at Hopkinsville. Wow, that was absolutely amazing, Renee. Can you even try to put it in words?
I can. I mean, I just have goosebumps all over my body.
Wow, this is amazing. We can see the birds flying around in the
we can
distance.
see the sun starting to come out, and it's getting bright again.
This is amazing.
It's really a once-in-a-lifetime opportunity.
Yeah,
Until the next eclipse
Yeah,
that we'll
exactly.
have only 6 years away, we get to see it again.
Wow, we'll be there.
Yeah.
We will be making
Without
our
a
way.
doubt. I think I'm hooked. I'm an addict.
We have sat in meetings preparing for this for the last 2 or 3 months, and now that it's actually here, it's completely 100% lived up to its billing, and I can't imagine, I can't believe what just happened.
It was just amazing. We were so worried about the weather and the the broadcast and making sure our telescope was set up and everything went smooth, and we just had a blast.
Wow, this has been absolutely amazing. Folks, we have really enjoyed it. It's been a great time here at Hopkinsville, here at Eclipseville, USA. Now time for us to send it back to Clarksville, Tennessee, where our good friend Chris Blair is standing by for their reaction to the eclipse. Chris?
Well, I I think he meant Charleston, not Clarksville. So let's bring it back here at Eclipse Central. There's only one Eclipse Central, and it's here in Charleston. Yeah, okay, so the hits just keep on coming through the eyes of NASA. Now, let's continue. Now, these are going to be pre-recorded views from the high-altitude WP-57 aircraft. They soar high above the clouds that could potentially block the views of today's eclipse. And they're chasing the total solar eclipse. They're mid-wing, long-range aircraft used to conduct high-altitude research. So, let's go to these pre-recorded views.
Yeah. Yeah.
Okay. Yeah. What are we seeing here, Alex?
So right now we're looking at these specially fitted cameras. They're on the nose cone of the WB-57, and these are designed to look at the corona, and they're also designed to look at Mercury. They're taking thousands of images every minute and processing this data to give us an extended view, because up there at 50,000 feet, it's 20 to 30 times darker than it is here on the Earth. Because there's a lot less scattered light. So this is a really unique opportunity. As those two planes fly in tandem, they give us about 8 or more minutes of a view of the corona. Now, the other thing they're actually looking at is, because they're so high up, it's very cold, and that allows them to take infrared observations. And in this case, Mercury is very close to the sun, and they can take infrared observations of Mercury to see the temperature change as Mercury is rotating.
That's amazing. So we're going to come back with that, but let's go, now let's go to Clarksville and see what's going on there.
All right, thanks and welcome back. We're excited to highlight some of the student science and the STEM aspect of this solar eclipse. We have several students joining us right now. Would you please tell our audience your name and what school you go to?
My name's Eliza Dellert. I'm from the University of Alabama, Huntsville.
And what club or group are you with?
I'm actually with the Space Hardware Club.
All right, and you guys have been launching balloons all day today. Tell us about the scientific payloads and the instrumentation.
Well, on our first balloon, we had a Geiger counter counting alpha, beta, gamma particles. We also had a pointing payload to get stabilized camera footage along the way. We had some hops from one of our local breweries. And then we, on our second balloon, we had a live streaming payload. So that was cool. That was probably our biggest project, thanks to Alabama Space Grant and National Space Grant. And so we were really excited with all of our experiments. They went really well.
Excellent. Well, we're glad you came here to do this. We appreciate it.
I appreciate it.
Thank you. And so that's University of Alabama in Huntsville. And so we also have another student joining us from the Space Camp, U.S. Space and Rocket Center in Huntsville, Alabama. Tell our audience, please, your name, and I just said who you're with. So tell us your name, please.
I'm Stephanie Bonifield. I'm from Pittsburgh, Pennsylvania.
And you're with the Space Campers. What have they been doing all weekend long to get prepared for this eclipse?
Well, the day before we left, we did a whole bunch of eclipse stuff. We did classes about what the eclipse is and like what we'll experience, and a lot of safety stuff. They didn't want anybody like burning their retinas or anything, so we did a lot of that. We talked about what experiments we'll be doing. We set up the shadow band boxes that are over here that are out of the shot, but we recorded, hopefully, some interesting data about what was happening during totality, so that's pretty cool.
So you guys will go back and go over that data a little bit. Tell us about the students. Where are they from? It's not just students from Alabama.
No, yeah, we have students from all over the country and even all over the world. We have students just in my team who are from like Spain. We've got someone from Norway, all over the world. It's crazy. There's a girl in another group who's from Mexico and a boy from Mexico, and they were like talking to each other in in Spanish the other day, and that was really neat, just meeting other people from other cultures. So you really get a neat experience at camp.
Absolutely. Education is global. And so lastly with you, give us your first reaction to viewing the solar eclipse.
It's just really crazy. It is daylight here, and it was daylight before, and then the eclipse kind of comes in slow, and it's just like a glowing ring in the sky. It's incredible. It's so hard to explain. And then the lighting, it's not like dark like at night. It's like this kind of almost eerie sort of ambient lighting. And there's a sunset everywhere. And then after totality, like right after, it was like somebody turned daylight back on. The moon just moves away and it's light again. It's really awesome.
No, absolutely. It's exactly what happened. So thanks. We appreciate your time. Yeah. Thanks a lot. So we got one more student joining us. It's from the Inspire Project. Please tell us your name and what school you attend.
I am Robert Allsbrooks, and I attend Chesapeake Math and IT Academy in Maryland.
And tell us a little bit about the science experiments and research you were working on while you were here.
I was working with the balloons, and I was also working with the shadow bands and the ham radio.
All right, and how about your first reaction to the solar eclipse?
It was just amazing. When I saw the sun go away, and it almost went pitch black, and I just looked up, and it was just a ring around the sun, and it was amazing. That's all I have to say.
I appreciate it. Thanks a lot.
Thank you.
On behalf of everyone here at Austin Peay State University and NASA's Marshall Space Flight Center, thanks for letting us be a small part of this wonderful event. Right now, let's go back live for continuing coverage of this eclipse from Charleston.
Thank you. We are having a great time here at the College of Charleston, but we've got more images coming here and the International Space Station later. Let's get some images coming in from the Great Smoky Mountains, one of the largest national parks east of Rocky Mountain. Wow. Alex, what is that? Looks awesome.
We're looking at the sun that's still too bright.
It's still too bright.
But it's almost completely covered. It's getting dimmer and dimmer. And this is the unfiltered sun. So we're going to go straight from this to
Totality.
seeing the corona directly. This is going to be a pretty cool shot, actually.
So here's
you can
still,
see it's
glasses
getting
still
dimmer
on.
and dimmer. Still got to have your glasses on. It's still too bright to look at directly. But it's just almost like a little tiny Christmas star or something. It's crazy. It's getting tiny and tinier.
Now, why was it in the shape of a star? That's the first one I've seen.
That's oh, there it is. I can see the corona.
Oh, okay.
That's because the camera itself didn't have a filter on it, and it was too difficult to see. But we can see the corona. There's now a little black dot, and you can see the corona around it, and that's actually the closest to what we're going to see when we look at it with our own eyes when we view it here.
John, let's go to social, man. They got to be buzzing on the conversation here.
Yeah, there's a lot of questions coming in. Of course, it's trending all over social media. Let's pull up this image right here on the sidebar, if possible. This right here is just one of our users did of the eclipse from Arlington, Texas. Pretty freaking cool. Showing the partial eclipse on his hand, really interesting. And then we have the Toshiba screen in New York City, where, of course, everyone there in Times Square is able to see the partial eclipse. So it's pretty spectacular. Views coming in. And we do have a few questions. I'd like to just try to get a couple in. Is it okay to see a solar eclipse in selfie mode? I see a lot of people, there's students out here, and students like to take selfies. Is that without glasses? Is that okay to do?
Actually, it is if the sun's especially behind you, because if you're looking down, the sun's behind you, and you've got it in selfie mode, that actually will protect your eyes. Again, the main thing is you do not want to have it pointed directly at the sun so that you might move away and see it with your unprotected eyes.
Yes.
So let me use this opportunity to talk about safety reminders too, about just making sure, like you just said, it's the overall view.
You know, if you're in the partial solar eclipse, make sure that you always have your glasses on to look at the sun. The only time that is safe to take off the glasses is when you're all completely, like the moon completely blocks the surface of the sun in totality. As soon as you see that diamond ring effect, that's the timing to actually put back your glasses to look back at that amazing event.
And John, let's get one more social question before we go to the next phase here. We're just having too much fun here.
Starting to get cold and dark here too in Charleston. I think this is pretty obvious by all of us outside right here, but is it safe to be outside during the eclipse as long as you don't look directly at the sun?
Absolutely. There's nothing different. We are just having less sunlight shining down on us, but there's no real difference, and it's absolutely safe to be outside. And we, of course, as long as you're safe, encourage that.
Yeah, go outside and watch this event.
Okay. All right, here we go. So let's talk about exoplanets. A solar eclipse is a special kind of transit or movement of astronomical body that passes in front of another. And if you've been watching along with us, you know NASA is using today's transit to further study the sun. We use similar transits to study planets outside of our solar system, or as I said, exoplanets, as they pass in front of their distant star.
While a total solar eclipse is a rare opportunity to learn more about our sun, NASA's Kepler mission has been studying distant stars for an eclipse-like event called a planetary transit. Using a space-based telescope, scientists from Ames Research Center have been measuring the changes in the brightness of stars as their planets orbit or transit in front of them. Kepler has confirmed more than 2,500 exoplanets, or planets beyond our solar system. Many of these are similar to Earth in size and distance from their sun. Studies using Kepler data have revealed a vast range of planet types and sizes, and future discoveries could help enable the search for life in the galaxy. Another major effort at NASA Ames to use eclipses to study stars in deep space is called SOFIA, or the Stratospheric Observatory for Infrared Astronomy. SOFIA is a modified Boeing 747 SP aircraft that makes celestial observations in the infrared part of the electromagnetic spectrum. Flying up to 45,000 feet, SOFIA operates above 99% of the Earth's water vapor that absorbs most of the infrared light from space. One example of SOFIA's unique qualities as an airborne observatory occurred when researchers recorded infrared imagery of Pluto as it eclipsed a distant star. What we learn from missions like Kepler and SOFIA could help us to better understand the mysteries of our sun, our galaxy, and our place within it.
All right, thank you. We're here live at the College of Charleston in Charleston, South Carolina, where it is just about time for Totality. And I'm here with my colleagues, Dwayne Brown and John Yembrick, and Jari is somewhere, I believe, Carla Vega, and Alex Young. And you can see the crowd behind us. And if you look up in the sky, which I was doing just before we came back here live, we are probably at about 90% totality. And the good news from the weather standpoint is there are some clouds, but I see some breaks in them just off to the south a little bit, and fingers crossed, really tight that those breaks are going to move over as we get into totality in just a few minutes. Dwayne, what do you have to say about that?
Well, first of all, I want to thank you for, hey man, we got something. You are the man. You are the man. This is exciting. We've got our glasses. We got our scientists. Johnny, come on, get in here, and Alex here. So we're excited here at the College. Make some more noise, College of Charleston. Yeah. We are having a ball here. There's still a lot more here through the eyes of NASA. We got the International Space Station coming up. You don't want to miss it. But here we go here. Safety glasses on, guys.
Let's get in there, yeah, but we still got maybe a few more minutes to go till totality, but you can see, look at that, you can see that, yeah.
Wow. Johnny, you know, even with the clouds, we can still see it. It's pretty good, right?
You guys see it?
Yeah. A little bit.
All right. I think we got some break-ins in clouds. I can see.
We got a couple minutes. We still got about 3.5 minutes left.
Guys, this is amazing, right?
This is amazing.
Through the eyes of NASA. College of Charleston is getting a large selfie with the students and faculty and everyone here.
2.5 minutes left.
2.5 minutes. Dwayne, you've actually seen a total eclipse before.
I have, and it's amazing, and it's spiritual, and it really brings you in step with that. We're just a small pebble on a highway of galactic endlessness.
Does viewing this right now bring you back to that moment several years ago?
It's a little different because I'm here on American soil with you guys here, but it's still breathtaking.
Amazing. Yeah.
You know, Sean, I haven't seen it in Africa and here in the U.S. Doesn't get any better than that, my friend.
No.
Here we go, almost. Here we go, it's coming. Johnny, what is it there? Is it there yet?
No, it's hard to tell. I think that was just some cloud cover.
Getting dark.
It's getting dark and it's getting cooler too, which is nice.
The temperature has dropped.
Yeah. We're still. I don't think we're quite there yet. We've got some patches of blue just a little ways away. Still just an amazing experience.
I have goosebumps. Like, this is...
Yeah, you've done...
It is safe to remove your glasses and look at the total eclipse. You may remove your glasses.
We've got a minute and a half, right?
Yes.
Totality.
A minute and a half of totality. So we have.
Once again, it is safe to remove your glasses and look at the total eclipse.
Yeah, that's it. Wow. Put the glasses back on now.
Glasses back on. Yep.
Please replace your glasses. You need to put your glasses back on to view the sun now. Please replace your glasses. You must be wearing your glasses to look at the sun.
I mean, we experienced the temperature drop,
Yeah.
and it was dark. It was dark. 2024.
Yep. Ready for the next one.
I got IFB in your ear, Sean. Okay, Sean, this is your first, right?
This is my first, but certainly not my last.
How did it feel?
Amazing. You said it yourself, Dwayne. This is amazing. That's the only word to really describe it. You know, even though we had the clouds, it was just an incredible experience. We got to experience the darkness. We got to experience the temperature drop. We got to see it in, you know, kind of moving in and out between the clouds. But most importantly, we got to experience the energy and the enthusiasm that we feel all around us here today.
Well, you know, this team in the city of Charleston, well, thank you. We had some iffy weather, but you made it happen, man.
Yeah, well, thank you. And you don't know the half of it. Actually, I've been also monitoring for possible thunderstorms, which we are having. We've been having just up to the north in places like North Charleston, Goose Creek. Luckily, because of a sea breeze pushing the moisture that's been bringing. Allowing these clouds to develop, moisture coming in from the Atlantic. That sea breeze has been pushing those thunderstorms inland a little bit. So even though we still have some cloud cover here, we have been very lucky not to have any rain or thunderstorms like we had yesterday at this time.
You are really a true meteorologist, my friend. Johnny! Hey, Johnny! Okay, space weather expert extraordinaire. How was it?
It was amazing. Like Sean said, even though that we couldn't see it, you know, consider the solar corona, which, you know, is what I really, really wanted to see. We experienced, you know, the darkness and the change in temperature, and also, I mean, the energy of the students. You know, we even started hugging up because we were like so excited. I mean, it has been an amazing experience. So the next one, you know, 2024.
Hey, Alex. You gotta feel good, man.
This was fantastic, and it was also a big tease for the next one, because man, I want to do this again. I could feel that shadow overhead. I could see the light and the horizon all the way around, feeling the change in the temperatures, even seeing the clouds themselves moving differently as that shadow hit overhead. It was fantastic. It was palpable, man. I could just feel the energy around here. And I want more of this.
Well, let's hear what the country and all of this in Charleston. Let's go to social media. Over to you, John.
Yeah, the reactions across the entire nation have been huge. You know, we have, actually, if you're watching at home, some of our streams actually went down only because the fact that, you know, there was just so much traffic on it. Of course, we were broadcasting this all over the country. I want to show up on our some of our graphics here, some really cool things, photos that we have here, some crescent-shaped shadows in Seattle, Washington, taken by Logan Johnson. This is a pretty interesting image, as you haven't really seen anywhere else. The next one here is a totality view from Idaho Falls. This is David Cantillo. Just some spectacular images coming in from all over. You know, people are sending us stuff using the various hashtags out there. Eclipse 2017, which is our hashtag, Solar Eclipse 2017, which is trending on Twitter and other places. And of course, we're reading a lot of this stuff coming in too. We're seeing and reading your reactions. Some of it is just really shows the amount of how it really impacts people. And us being here in Charleston, we also saw it get really dark here, get cool breeze coming through. And even though there were some clouds, it was like nothing we've really ever experienced before. And so for those of you who are in the Path of Totality, I hope the views we're showing you here today have really helped you kind of get the sensation of what we're trying to show. And here's this last one here is a 99.5 near totality nerds here in Boise, Idaho, checking it out. One of our photos there. Everyone is wearing eclipse glasses, and it's you know, we still have a partial eclipse on the East Coast. People are still seeing the sun transit, and so it's an exciting time here. I think that I think we have another view here from Bailey Beads, seen from Oregon, from one of our photographers. This is a NASA photographer, took this shot right here. I think that's just before the diamond ring pops up, and it's pretty spectacular shot. So I think if we're ready to get going again, I think we have a quick question would like to take. Look at some of these here. There are a lot of these are questions coming in from eclipse viewing. Now the eclipse is officially over. I see that. What were your reactions as you were watching it? I know we were out there and stuff, but now that it's over, what's the sensation that having the totality behind you?
It was amazing. I got goosebumps. This is my first total solar eclipse. I actually remember watching, you know, a partial solar eclipse back at home in Puerto Rico, and I mean, was amazing. You know, like I said, the darkness that was around us. It was amazing being, you know, knowing that it's day.
I was just sort of amazed by the kind of rush of how quickly it all of a sudden happened. The darkness, and then I could just feel it all around me. It was really, really powerful.
Well, I'm glad it's really cool.
Yeah, I'm definitely glad it's cooled down a lot.
Yeah, it's cool because it was hot. It was hot.
It was very hot.
But the weather, I mean, it's amazing. And as we said earlier in the show, and when we watched it, this is my second one, but sharing it with you guys, I mean, this is very, very cool and memorable. And 7 years is another one? Is that right?
7 years in the U.S., but we've got one in 2019 in South America.
In Argentina.
So we'll start making reservations already. So this is certainly one for the history books. But we're not done yet. The solar eclipse is traveling over the Atlantic Ocean. So Alex, let me turn to you. How far is it going to go out to the ocean?
It's got another 3,700 miles roughly to travel. It's going to end just off the coast of Africa near Sierra Leone, in that area. But that's also where night begins, day ends and night begins. So we got a ways to go. There's still some more left. And maybe if you're out on a ship, you're going to get to see some more of it too.
Yeah, we have the Coast Guard 5 miles from Charleston.
Oh, well, that sounds pretty good. Well, you know what? I've been talking about this. If you just tuned in, this is NASA Television through the eyes of NASA. We have been bringing you unique images, reaction from all over the country. But now in 30 minutes, we'll be bringing you a view from one place no one else can go, the International Space Station. We'll check in with the astronauts aboard to see how they experience the eclipse from space. Here in Charleston, we will continue to see a partial solar eclipse for about 90 minutes or so. And remember to continue to use safe wearing, viewing, glasses, methods, and everything in between. Safety, safety, safety. Now we're going to my colleague, Karen Fox. Hey, Karen, who's out in the field getting more reaction. There she is.
We have been having a ball out here on the quad at the College of Charleston. Everybody had a great time today. We're going to ask a few questions for the people who were here. Why don't you step over here, young man? Tell me your name.
My name is Josh Petro.
And what year are you?
I'm actually a second year here.
So did you come to Charleston College, the College of Charleston, just to see this eclipse? Like, is that why you chose to matriculate here?
Oh, absolutely. No, to be honest, I love this school, and the eclipse, I've been studying the sky since I was probably 9. Since I could read, I'd take out astronomy books. So this is just once in a lifetime, honestly. It's amazing.
So tell me about it. What did you experience when you watched the eclipse? What did it feel like for you?
It was just like, wow, this is what you read in books. This is the kind of thing that you think, wow, if that happened to me, I don't even know what I'd do. And it happened.
It's fantastic here. So I have one more question. You said you've been studying space since you were young. What are you majoring in now? Are you studying science?
Actually, the plan was to do a double major of astronomy and physics, and hopefully maybe do some of that work myself one day.
Awesome. Come work with NASA. We'll look for you. Thank you so much.
Thank you very much.
All right. Let's find somebody else. You want to come on up? Come on over. Sure. Tell me your name.
Oh, my name is Amanda Anium. I'm a rising junior in the Honors College at CFC. I'm sorry, no, you didn't ask that, but.
But I was going to. That was exactly what I was going to ask. You're like a mind reader. Do you know what my next question's going to be?
How was my experience? It was amazing. I felt a total unity with the world. I did.
That is fantastic. So I have a question. What are you going to do with your eclipse glasses now?
I think maybe as a souvenir for my grandchildren. I think that's what I would do with my glasses.
You're going to be like, let me tell you, kids, this is where I was on August 21st, 2017.
Yeah, exactly. Yeah, she summed it up pretty well.
Fantastic. Thank you so much. We are going to go back to Dwayne Brown, and we'll be back later with more conversations from the college.
Thanks, Karen. It's always good to see the young and those. I see some inspiring scientists out there. Now, let's take a look at the highlights from today's events, and when we return, we'll learn more about how the astronauts viewed today's eclipse. Okay, through the eyes of NASA, only here are we bringing you the International Space Station live. It's traveling at 17,500 miles per hour as it orbits Earth. Now, from NASA's Johnson Space Center, we have Rob Navius in Mission Control. Rob, over to you.
Welcome to Mission Control here in Houston. About 40 minutes ago, the 6 residents of the International Space Station flew over southern Canada, south of Hudson Bay, at an altitude of 252 statute miles, with a very, very unique view of today's solar eclipse. We're going to be talking with the crew in about 18 minutes from now and sharing some of that very, very unique video with you. It was spectacular, I must tell you, and digital still imagery that Randy Bresnik has captured throughout the course of the first 2 of 3 passes the station is making over the eclipse throughout the course of the day today. That has already been posted on social media and will continue to be posted as the day wears on. But we're looking very much forward to talking to the crew and getting their impressions and thoughts as they passed over the eclipse just about 40 minutes or so ago. So we'll be back to you in just a few minutes with the crew of Expedition 52 aboard the International Space Station. For now, back to you in Charleston, Dwayne.
Thank you, Rob. And coming up later in the show, we'll have another unique eclipse view from space. We'll have imagery from NASA's Solar Dynamics Observatory. It's also about to see an eclipse. So, SDO, Solar Dynamics Observatory. Alex, tell us a little bit about SDO.
Well, SDO is one of NASA's heliophysics fleet. It gives us an unprecedented view of the sun. Incredible detail, incredible time and spatial resolution. It shows us 10 different wavelengths of light at the same time. showing us in mostly extreme ultraviolet light the sun's outer atmosphere, corona and chromosphere, where we can see all of the dynamic phenomena that's happening. It is putting down almost 2 terabytes of data a day, giving us these unbelievable views of solar eruptions, solar prominences, solar flares, and all of the activity on the sun that drives space weather, what Yari spends her days studying.
I mean, it's just an amazing mission because it lets you see in so much higher resolution the images from the sun that you can actually understand the origins of space weather and those solar flares, the corona's mass ejections. I mean, put it in perspective, it's like downloading more than 1 million pictures a day. That's how much data.
SDO, wow, that's incredible. Okay, so we're gonna go back to Karen Fox, who has a pretty important person with her. Karen.
All right. Hello, we are back, and I have Mike Massimino with me, a former NASA astronaut who was on the Space Shuttle twice. Hello, Mike.
Hello, Karen. Hello, everyone out there on NASA television. Good to be back on NASA TV.
We are so glad to have you here. Now tell me, was this your first eclipse?
Yes, this was my first eclipse. I think there's one that passed by my neighborhood in New York on Long Island when I was a kid, because they were telling us not to look up the sky and be careful and all that. I was like 9, I think, when that was a long time ago. So this is definitely the first total eclipse I've been a part of, and yeah, we'll see. We'll see when I can get to the next one. This was pretty cool, though. I'm glad I got to be here for this one.
Tell me a little bit about it. What was your experience? Did it live up to what you were expecting?
Yeah, well, I mean, there was certainly a lot of excitement. It was, it came right at the right time. I think all the science assets and resources that were out there trying to collect data and study the sun, that all went well. A lot of excitement throughout the country. A little bit too much cloud coverage here, though, in South Carolina. So, we maybe could have gotten a better view, but it could have been a lot worse, too. I think there are other parts of the country that got clouded a little bit worse from the weather. But it was really cool to be here, and it got cooler. I could see it, and I could feel it with the temperature, and I could hear it with the excitement of I guess predominantly a student crowd that we had here at the College of Charleston.
So tell me a little bit about what it's like, something that the rest of us have not been able to see, which is seeing Earth from space. Tell us a little bit about that.
The Earth from space is the most beautiful thing I've ever seen. It really is beyond words. It's like a look into paradise. It's just a beautiful planet. We're very lucky to be here. And I used to always count like the lucky things that we had here. We have an atmosphere that keeps us alive, and we have water that keeps us alive here on our planet, and we have a magnetic field that keeps us protected from solar radiation. But we also have a moon and a sun. The sun is 400 times larger than the moon and 400 times further away, so they're the same size in the sky. So we get a chance to have solar eclipses, which other planets in our solar system do not. So we're lucky for a lot of reasons, and I'm going to add solar eclipses to the list. But the beauty of it, the beauty of the planet, and also the sense of clockwork of this, this ballet, this dance that goes on between the Earth, the Sun, and the Moon. You can see that in space, and you can see the rotation of the Earth. What we call the terminator between night and day, and as that just steadily rotates, just like this clockwork going on. And that's what we witnessed today. This clockwork with the Moon involved, getting in the path of the Sun, and us all lining up perfectly together. And it's that clockwork that still amazes me, that everything has this permanence to it. It doesn't disappoint you. It's been going on for billions of years and will continue to go on for billions of years. The sun will come up tomorrow. These things will keep happening. It's a power, a force that we can't control. And to see it in space was cool, and now to see it down on Earth, that was cool as well.
That is a beautiful sentiment. Thank you very much. I agree. We've had an incredible day watching this. So how about 2024? Do you think you'll be lining up to see the total eclipse in 2024?
When's that? That's not too much long. Where is it going to be? Where is it coming that year?
That is going to go up from Texas up through Maine. It will be in 2024. We're excited.
So not coast to coast, but yes, that'll be good. I'll go.
And back to Dwayne Brown. Thank you.
Hey, thanks, Karen. It's good to see Mass, too. Now that the entire United States has experienced today's solar eclipse, let's go to social to see what people are saying, and they're saying a lot, I'm sure. Right, John?
Yeah, thanks, Dwayne. Yeah, we just captured a few reactions and want to show those to you here with some graphics. This person right here is loving NASA's game day today. He's giving some shout out to us here on the broadcast, which is really, really quite nice. This is another one of our Twitter users from Nashville. Just some awesome photos taken by users across the internet. If you use the trending hashtags out there, you'll see, and I've been looking in here on my computer, just some amazing photos taken from the public. Some amateur photographers, really looks like legit stuff all over the internet. Here's another one of our users. He wrote, "This was the pic of the eclipse I took through glasses. A second one I've seen in my lifetime, awesome." Here's another one. I'd like to thank the clouds for letting me look at the eclipse. It was so cool. We are not thanking the clouds here in Charleston, South Carolina, but we did get to, it's really, you could see it was bright. The sun was bright enough. You could see the partial eclipse with glasses through the clouds. It's just totality was a little bit of an issue. Here's another one on Twitter. It's very weird to be in a darkened home with not so much daylight at 2:45 p.m., yet the sun is still shining outside. And here's another one. Wife and I are currently gazing into the bottom of a box of frosted mini wheats per AdNAS advice. It's just making me hungry. And honestly, it was better than I thought. I think a lot of people across, that's one thing we're really seeing. I mean, everybody knew this was happening. I think the emotional experience that went with the eclipse, a lot of folks we're seeing online weren't necessarily anticipating that. I think it could be really heart-wrenching and scary a little bit, but also really emotional and spectacular. And here's another one. And any other day, I'd be concerned if I saw a line of people on the roof of a parking garage. Today, not so much. It is solar eclipse day. And here's our last one I want to show you all. I'm saying y'all. Y'all, oh my God, OMG, it was the coolest 2 minutes of my life. So I think a lot of people around the country were seeing that sentiment. This is the sort of celestial event that really has a big impact. We look at the sun every day, and we see it in the sky. It's a very constant for us. And all of a sudden, for it to be obscured feels a little unnatural. And I think that's one of the things we were really seeing across the internet. So thanks everyone for submitting your questions with the hashtag and for giving us your photos. We really appreciate it, and it's been a spectacular day for all of us.
That's the great thing about social media, the creativity and those things are like, it's just so awesome when they post those things.
You get honesty.
Yes, and we really, really appreciate your support for NASA, and keep those images coming in. Okay, so we've witnessed a total solar eclipse as it moves across the entire United States. And it's incredible to think about how NASA scientists are using advanced tools to image this eclipse. So Alex, before all of this advance and here, the cameras that people use that we have now, I think people used to draw the eclipses. Let's take a little history lesson.
Yeah, so, one of the things that's amazing, so looking at the sun and eclipses is actually the beginning of modern astronomy. And before we had cameras, people actually drew eclipses by hand. And in fact, this phenomena that Jari and I study, coronal mass ejections, were first seen in an image. So if you look at this image, I had an image up from this book. It's actually an image of a coronal mass ejection. But what you're seeing here are images from 1869 showing you the corona drawn by hand. But when we look back in the past, before we had cameras, we discovered helium on the sun. That was done during a total solar eclipse. We discovered the outer atmosphere was hot, and we even were verified general relativity in 1919.
Yes. And the image that Alex was going to show you in the book is actually like 100 years before we can actually see it with a satellite. Isn't that amazing?
Okay, you know what? I want to do something fun here. All right, we're having fun. Can we have some more fun? So, Alex, and for the young students out there and folks, the future generation scientists, as I told Alex earlier, he is one of the coolest looking scientists that I've seen. He's got the earrings, got the look, but he also has something even cooler. I got to show him the shoes, man.
All right, let's see if we can get this to work. Let's show them.
Oh, no, there you go.
There you go.
Flame shoes.
How cool is that, folks? So Alex, what got you into the heliophysics and the sun? A little background.
Well, I've been interested in astronomy all my life, seeing things like Star Trek and Carl Sagan. But when I was studying astrophysics in graduate school, my professor said, you ought to look at the sun. The sun is really close. and it's something we can study in incredible detail, and you can use this as a tool to study the rest of the universe. So that was when I realized that we can learn so much about our universe, why we're here, just by looking at our closest star, the sun, and all the incredible detail that we have. And this is the reason why scientists are so excited about total solar eclipses, because we can see a region of the sun in visible light with our own eyes that we cannot even see from space.
Fantastic. So, Alice, I'm going to come back to you because I understand you're a cat lover, and Jody, I know you have a fantastic story to tell. But we're going to go back out to Karen, who has another special guest. Karen, you're just having a good time out there.
I am having fun. The College of Charleston students have been fantastic supporting us today, and we have some more students here. Can you tell me your name?
I'm Nicole.
And tell me what year you are and what you're majoring in. I want to learn a little about you.
So I'm a senior at the College of Charleston. I'm studying biology. I want to do conservation work with like endangered species and fragile habitats.
Fantastic. So was this your very first total solar eclipse?
Yes.
And what did you think?
It was really awesome. I was glad I got to see it.
Tell me a little bit about what you felt when it got dark and got cold. What did you think was happening?
It was kind of just surreal. I didn't really know what was going on. I didn't expect all the lights to come on and stuff, so it was really cool.
How about the rest of you? How was your experience today on the total solar eclipse?
Unreal.
Yeah.
I'll never see it again.
You're going to see it in 2024.
Oh, really? And where? Where at?
We have another total solar eclipse across the United States from Texas to Maine, 2024. And of course, you could start traveling for them. Do you think you'll start traveling for them?
Probably not. Honestly, it was cool, but I don't know. It's kind of a once-in-a-lifetime type of thing. Yeah.
All right, I'm going to ask you my favorite question I've been asking students this week. What is the music you associate with the sun and space and the eclipse? Give me something.
Here comes the
Dark Side of the Moon.
Sing it for me.
Nah.
Come on, come on. Okay, here comes
the sun.
Clap for it.
Here comes the sun.
Thank you very, very much. We are doing well here at the College of Charleston, having a great time. People are beginning to leave the quad now and moving on and going on to start school tomorrow, right? So is this like the best start of school ever?
Yeah, definitely. I couldn't have started like a different way. It would been awesome.
Fantastic. We've got one more person here. Do you want to come over? Come on. Tell me a little bit about what you experienced. Was it like what you expected? What did you expect?
I expected it to get dark, but I didn't expect that temperature to change and get so cold.
I felt the same way. I was really surprised. I kept thinking it was going to rain or something, and it never did. It was fantastic. All right. What are you going to do with your eclipse glasses now?
Just keep them as a souvenir. I might put them in a scrapbook.
Oh, I like that. Don't use them if you ever get them scratched, okay? Okay. If you keep them pristine, you can use them again, but not if they get scratched, okay? You're going to be real careful with these, right? All right, fantastic. Anybody here a science major? Any one of you guys? You are? Come on up. Oh, look at your shirt. Look at your fantastic shirt. Wow, tell me about your shirt.
I don't remember where I got this, but it's obviously constellations, and it seemed appropriate since it was astronomical.
I agree. And what kind of a science major are you?
Geology and biology, probably.
And do you say that this inspired you a little bit more and be excited about science?
Yes. Really amazing.
Thank you very much. I'm so glad you all were here today, and we are going to hand it back to Dwayne Brown. Thank you so much.
Thanks, Karen. You know, and they are special guests because, you know, the kids and our future scientists are really, really important and special. And Jody, I know the audience wants to hear your story. I mean, it's amazing. I mean, we're sharing here. Tell us your story.
Well, I mean, I started interested in science since I was a little kid. I was very curious, but it was when I remember I traveled to Florida. I have family in Florida. I was 6 years old, and I went to the Kennedy Space Center, and I saw the amazing things that NASA had there. I put in my mind, I want to work for NASA one day. And coming from a little island, you know, Puerto Rico, hola Puerto Rico, I mean, I have to work really hard, but it's, you know, here I am. I work really hard, and it has been an amazing experience, and look where it got me.
Oh, my goodness. Well, I'm glad to be here. It's been a great day. So, ladies and gentlemen, we've been talking about this. Now it's time to go back to the Johnson Space Center to Rob Navis and the International Space Station coming up. Rob. So, okay. Not yet. So, what we're going to do, we're going to come back here. I just love live television because you But, so, now we can talk about cats. Cat
yes.
man.
I'm a cat
Let's
man.
go.
I'm a cat lover. Yeah, so, you know, I love cats. I've always had cats. My wife has cats. And the great thing about it is they're such great companions, and I do a lot of traveling for NASA. And it actually is very convenient to have a cat because they let you go away, come back. They're still glad to see you, but they don't need quite as much care as a dog does. So actually, for all the work I've done and all the time I've spent out studying the sun from other countries, cats have always been there for me. So
2 quick questions, and then we are going to go down to Houston. Advice for becoming a scientist, real quick.
Well, study. It sounds simple, but just keep going to school, but try as many different things as you can, experience in different opportunities, internships, things like that, because it gives you a chance to really see the breadth of science and technology out there.
Jody.
Keep motivated. You know, like Alex said, do the internships, try different things, because you never know exactly what you really like, and to be really happy on your job, you really have to find that calling, what you really, really love.
Yeah, and for the folks and the kids and the students watching, and a lot of you out there, I mean, look, Alex and Jody, I mean, they're amazing. They're amazing. And we'll hear more about them. Now, within the past hour, as eclipse swept across the continent, U.S. 6 crew members aboard the International Space Station had a chance to view this phenomenon from a unique vantage point. Let's go to the ISS Flight Control Room at the Johnson Space Center in Houston. Rob Navius, back to you with more. Rob.
Thanks, Dwayne. You know, millions of people have been witness to this amazing event across the United States throughout the day today. But up on the International Space Station, members of the Expedition 52 crew have had a unique celestial front row seat to history. About an hour ago, the International Space Station flew 252 statute miles above the Earth over southern Canada as it made its way south of Hudson Bay with a tremendous view of the moon's shadow against the Earth. The moon covering about 44% of the sun during the second of 3 passes. You can see it in this animation right here. The crew were glued to the windows of the International Space Station with an HD video camera, with an armada of digital still cameras to capture every moment of those precious seconds. With us at this hour aboard the International Space Station in the Destiny Laboratory of the complex are 4 of the members of the Expedition 52 crew, NASA flight engineers Peggy Whitson, Jack Fisher, and Randy Bresnik, and flight engineer Paolo Nespoli of the European Space Agency. Thank you all so much for joining us today on this historic day.
Yeah, it's been an exciting day for us to have the opportunity to see the eclipse from here.
Peggy, let's start with you. You were in the cupola with an HD video camera looking out at the limb of the Earth where the shadow appeared, capturing some spectacular video that we're going to replay here in a second. What were your thoughts and impressions as the station flew over the shadow of the Earth?
Well, I'd seen pictures from previous eclipses, and so I think I had underestimated what this would look like. This was much darker than I gave it credit for being. Unfortunately, it was kind of near the limb, near the edge of the Earth from our view, so several 100 miles away. But it still was impressive to be able to see that dark spot as we passed by.
For Randy Bresnik, Randy, you've been looking forward to this event for some time now. Your thoughts and impressions of the eclipse. You also shot digital still imagery of it as well. And what does a solar eclipse do to a human being? What does it do to a human being in terms of understanding our place in the universe?
That's certainly a big question. You look down at the size of the shadow, and we've gotten used to the scope and scale of what the Earth looks like from here, and just understanding how many people will be affected by that. And a friend of mine the other day, mentioned that, and it kind of really came to me, we were actually looking at it, was that just a few hundred years ago, human beings wouldn't have even known that the eclipse was coming. And so here you are looking up, and all of a sudden the sun is